Okay, y'all, I got my iPad back. So you guys have been practicing with complex numbers now, and we're about to move into a unit where we solve quadratics. So what we're going to be needing to understand is something called complex conjugates. And actually it's true of all conjugates. The stuff that we're about to talk about works for all conjugates. So when you have a complex number a plus bi, the conjugate of that is a minus bi. Now, as I said, I'm not going to harp on this too much, but as I said, that's true for all binomials. So let's say I gave you just x plus 2. It's got a conjugate. Its conjugate is x minus 2. So conjugates are two binomials, meaning they've got two terms. So term 1 is the x and term 2 is the 2. So they've got two terms, and they're identical except for the sign in between. Okay? So what that means, oops, I went to do my eraser. There we go. So when you have a complex conjugate, something special is going to happen. So we're going to have a plus bi and a minus bi, and they're going to be conjugates of each other. So when we have two conjugates of each other and we FOIL them, okay, and remember you can use the box that we talked about in class today as well, and I'll be happy to show you that to you when I'm there on Thursday. But when you FOIL those two binomials together, something special happens. So when I do the first terms, a times a, I get a squared. When I do the outer terms, so then when we do the outer terms, a times negative bi, we get minus abi. Then we'll do the inner terms. So we'll do those two terms right there, which will give us plus abi. And then we get the last terms right there. And so we're going to do b times b. So we get minus b squared. And we do I times I, which gives us I squared. And so a couple of things are going to happen. The first thing is that the outer term and the inner term, they're opposites of each other, so they're going to add up to 0 and cancel out. And the second thing that's going to happen is that this I squared right here is going to become negative 1 like we talked about in class. And so what we'll have is we have this negative b squared right here, but now it's being multiplied times negative 1. So it becomes plus b squared. So there we go. When we took this complex number and multiplied it by this complex number, what we're left with is this. All the i's went away, and we were left with something real. Okay, and that's going to be very handy later. When we do a plus bi and it gets squared, remember that squaring anything means multiply it by itself. So that means we're doing a plus bi times a plus bi. And unfortunately that means that the imaginary numbers aren't going to cancel because those are not conjugates of each other. So when we FOIL that one out, the first terms will give us a squared. The outer terms will give us plus abi. And the inner terms will also give us plus abi. And then the last terms will give us plus b squared, I squared. So we're still going to have two things that'll happen. It's just not going to simplify as much. We're going to have our a squared. These two terms here in the middle, now they're like terms, and they're identical, so they're not going to cancel each other out. They're going to add together and give us 2abi. And then here, this I squared is still going to become a negative 1. And so what that means is that we now have b squared times negative 1, so we get negative b squared. So that's what that becomes. If we took that very same process and we applied that to a minus bi, that means we're doing a minus bi times itself. So we're going to square a minus bi and FOIL it out. Our first terms still give us a squared. This time our outer terms and our inner terms give us minus abi and another minus ab. I. And then this time, negative b and negative b gives us positive b squared, I squared, so the end term actually ends up being the same. So we have our a squared. Our middle terms here, this time they combine to give us minus 2abi. And then, like I said, that last term ends up being the same because I squared becomes negative 1 times the b squared gives us minus b squared. Okay? So it doesn't work out as pretty when you're not multiplying conjugates together. So this right here is just a summary of those three problems that we just did, what we got when we did a plus bi times its conjugate, and then a plus bi times itself, and then a minus bi times itself. So that's just a summary for you to refer to. So if we look at this first example, I've got negative 1 plus I square root of 5. That's my complex number. Its conjugate would be negative 1 minus I square root of 5. So remember, they're identical to each other except for the sign in between. So I'm going to go ahead and I'm going to put them in parentheses because it did ask us to find the product. So I'm going to go ahead and FOIL them together. So when I FOIL them together, let me change colors again. I'm going to take my first terms and multiply together and give me positive 1. Then I take the outer terms and multiply them together and it gives me positive I square root of 5. Then I take the inner terms and multiply them together and it gives me negative I square root of 5. And then last but not least, my last terms. So I have positive I times negative I. That gives me negative I squared. And I have square root of 5 times square root of 5, which gives me 5. And so then I just need to simplify. So these two terms are opposites of each other. They're going to cancel each other out. I've got my 1 up here in the front still. And then I've got the minus sign right here. I squared is negative 1, and it's being multiplied times the 5. And so when I multiply all that together, this is going to become plus 5. And so I get an answer of 6. A nice, pretty, perfect whole answer for that problem. Okay, so I'm going to give you guys a second to try a couple, but I did want to remind you of a couple things. First, these two are not like terms, so they're not going to combine. You don't have to worry about common denominators in this case. So the conjugate of this one is just going to be 3/4 minus 1/5 I, and I'll give you a second to multiply that out. And then this second number over here, it doesn't look like it's complex, but that's because there's a 0, an invisible 0 in front of it. So it's 0 minus 5i, and that means that its conjugate would be 0 plus 5i. Now what that does mean is that for this problem, you're not going to have to FOIL. You didn't have to write the 0 there. You could have just left this as negative 5i, and the conjugate of it is just positive 5i. So you don't have to FOIL that one. So I want you to pause it, and I want you to try working those two problems out and see what you get. Okay, hopefully you paused it. Okay, if not, please pause it now and try those problems. So I'm going to take my first terms here, 3/4 times 3/4 gives me 9/16. Then I take my outer terms, 3/4 times negative 1/5 gives me negative 3/20 I. My inner terms, 3/4 times positive 1/5 gives me positive 3/20 I. And then the last terms right there, I've got 1/5 times negative 1/5, so I've got negative 1/20 25th, and then I times I is I squared. So once again, these two terms are going to cancel. They're opposites of each other. And so I've got 9/16 minus, and then I've got my 1/25 right there. And my I squared is going to become that -1. And so then I have 9/16, and it becomes plus 1/25. And then you would need to deal with the common denominators so that you could add them. So you would need to figure out, now you could just take 16 and 25 and multiply them together to figure out what your common denominator is. Or you could actually figure out if there is a least common denominator, and you could add them. In this particular case, the least common denominator is their product. It's 400. And so I would multiply this by 25 over 25, multiply this by 16 over 16. And so I would get 225 over 400 plus 16 over 400. And so my final answer would be 241 over 400. So, I mean, it's not a pretty answer. It is a fraction. It's a relatively ugly fraction, but there's no more imaginary numbers at the very least. So it is prettier in that regard. And then this second problem that I asked you to pause and try, because you don't have to FOIL, all you have to do is just multiply this times this. You get -25I squared. But then that I squared becomes -1. And so you just have -25 times -1. And so you just get positive 25. There you go. Okay, so this one right here, you can compute the special products using that reference that listed those special patterns, but I think in some problems it's just faster to go ahead and multiply it out. So we're going to go ahead and FOIL these two conjugates together. So the first terms should give you 4. The outer terms give you minus 14I. The inner terms give you plus 14I. And the last terms give you minus 49I squared. And so those two cancel. And we've got the 4 up here in front. And then the I squared is -1. And so we end up with 53 as our answer. Okay, in this case, the next problem, I would actually recommend that you go ahead and write it out. Okay, -3 plus I squared is -3 plus I times itself. Because then you can actually just walk yourself through the foiling process. Otherwise, you have to memorize special patterns and all kinds of shortcuts and stuff. So when we FOIL, our first terms give us 9. Outer terms give us minus 3I. Inner terms also give us minus 3I. And then the last terms give us plus I squared. Okay, and so we end up with 9 minus 6I. And then that I squared becomes a -1, so it becomes a -1. And so we end up with 8 minus 6I. Really quick before I forget, anytime a problem says to write your answer in A plus BI form, this right here, the real part is 53 plus 0I. But technically speaking, it's not like I'm going to count it wrong if you just write it as 53, because 0 times I would become invisible. You don't have to write things that we know are there, but they're just invisible. So I'm not going to penalize your grade if you don't write it in A plus BI form, just so you know. Okay, and then I want you guys to try this one final problem for yourself. So once again, pause, give this one a shot, and then I'll walk you through it after you resume. Okay, so hopefully you paused. And once again, I'm going to go ahead and suggest that you write it out. 5 minus I square root of 3 times itself, because we are squaring it. Okay, and so now I can FOIL. So first terms give me 25. Outer terms give me minus 5I square root of 3. Inner terms also give me minus 5I square root of 3. And the last terms. So I've got, let me switch colors so it'll stand out. I've got negative I times negative I, which gives me positive I squared. And I've got square root of 3 times square root of 3, which is 3. Okay, so I've got my 25. These two are going to combine to give me minus 10I square root of 3. And then over here, the I squared will become that negative 1 again, times 3, which is going to make this become a minus 3. So I end up with 22 minus 10I square root of 3. Okay? So if you have any questions, just jot them down. You can remind message me if you want to, or just jot the questions down, and when I come back on Thursday, we'll do some question and answer time again. You do have a quiz on Friday over this new material since our test. So over simplifying radicals and complex numbers, that kind of stuff. So we'll make sure that you're ready. If you want that optional practice, I can write that for you too. I'll see you guys later.